4.10, number 483. Similarly, we need to find cap f of x, right? Find that if f of x is sine squared times cos. Okay, this is very similar to the last argument we had. We again see the derivative of one outside of the other one, right? Multiplied on the other one. So even though the derivative sine squared is not cos, but the derivative of sine is cos. So therefore, it's a very similar argument we had before, and you can approach it either way. I would say just bump up the power by 1. Let's think about it this way for a moment. Perhaps our original function, I'll just take a stab in the dark here. Perhaps capital F of x was something like sine cubed, right? 1/3 sine cubed x. Because a minute ago, when the sine function was to the first power, right? It was sine times cos. It was reverse engineered to be 1/2 sine squared. Right? Because we saw that the outer function was probably something like a half x squared, because we saw that the outer function's derivative looked like x. So to here, perhaps the outer function's antiderivative is 1/3 sine cubed, because the outer function's derivative here was really an x squared. Okay, and sine has been put inside the x squared outer function derivative. Okay, that's a big mouthful, but once you work through the first problem very thoroughly and think about it consistently for a few moments, this down here seems very reasonable as the antiderivative. Now let's just check it to make sure. Right? Again, all this is trying to reverse the process of chain rule. Right? Even though this comes as a product, we're not trying to undo a product rule. It's not really what's going on. It turns out that these particular structures, because they see the derivative of one of these functions next to the other one, and we know that's how chain rule tends to look, right? The derivative of some function multiplied on the outside of an expression like that. So that's what we have. So we're pretending that sine x was the inner function, and x squared, right, the function it was put into, right, it's like you have x squared here, and then that's being composed, right, with the sine x function. And all that's being multiplied on to cos x. Okay, so it looks like the outer function's derivative must have been x squared. That means the outer function originally must have been 1/3 x cubed, but I've got to keep the inner function the same for chain rule. So this transforms into this kind of expression, 1/3 x squared, but in place of x, I have the sine function. Okay? So with this guess in mind, we can go ahead and differentiate just to make sure. Bring the 3 down. So the 3's cancel. You get sine squared x, but the derivative of sine is cos. C goes to 0, of course. And I do get exactly sine squared cos, which is the integrand here. So therefore, this must be the antiderivative of this, because this is the derivative of this. Okay? Now again, that may not be so helpful because it is a lot of thinking. It's a lot of intuition that may not have been built yet. So let's approach it from the u substitution viewpoint. That might make it a little bit easier to digest, perhaps. So we would say that let u equal sine x, just like we did in the previous problem. So therefore, again, du will be cos x, and I'll multiply dx over here, dx. So our integral gets changed, right, into sine x is now u, so this is u squared. Cos x dx is du. And here again, right, like I was saying, there is our outer function derivative. We're now going to anti-differentiate that to get 1/3, in this case u, 1/3 u cubed, right? So 1/3 u cubed plus c, but u was really sine x, and I replace this with sine x. We get the same thing, you might say, without thinking so hard. So if a person wants, they might go to 5.5 and work through those problems first before they come to some of these, you might say, more challenging problems of these products here, because they're really just undoing chain rule. They have nothing to do with product rule whatsoever. And if it's very difficult to see the chain rule going on here, which I admit it is, especially your first time going through these kinds of problems, it can be very challenging to see how there's a chain rule involved at all in these kinds of expressions. Then it might behoove you to go ahead and look at use substitution in 5.5 before tackling these type.